Welcome, ladies and gentlemen, to the group exhibit Hydrogen, Fuel Cells and Batteries at the Hannover Fair 2018. I invite you all to sit down, order a drink and enjoy the next interview. My name is Falco Haag and I will lead you the next 20 minutes through our following talk. Our interview partner is now Dr. Hans-Jörg Fell from the HydrogenPro in Norway, where he is CTO. Last year, he announced to fill the gap of efficient large-scale alkaline electrolyzers. And now he will speak with us about a commercial hydrogen production for large-scale renewable energy projects. Please welcome Mr. Fell. Oh, have a seat. Hello. Hello. And to the audience, if you have specific questions, just feel free to take the microphone and join the discussion. Okay, let's start. HydrogenPro is co-exhibiting with THE on the Hannover Fair right now. Can you tell us something about this cooperation?
Yes, hello everybody. It's good to be back here in Hanover. And like last year, as you said, we are co-exhibiting with Tianjin Mainland Hydrogen Equipment, in short, THE of China. We have a very close collaboration with THE, and together we offer first-class hydrogen plants based on the core electrolyzer technology of THE. And THE is one of the big players in electrolysis. They have been in the business since 1994, and their stronghold is high-pressure electrolyzers, alkaline pressure electrolyzers. And they have since then sold almost 400 units. And together we can offer first-class products. And what is special about these products? Yes, they combine size, flexibility, and cost efficiency. Exactly what you need for large projects.
Okay, and what is the specific role of THE in this partnership right now, looking on the markets?
Well, THE, they are the supplier of the core technology, the high-pressure electrolyzers. They also produce their own hydrogen purification units, and we, as HydrogenPro, we represent exclusively THE both in Europe and North America. And we design hydrogen plants around the THE technology.
Okay, thank you. Before we come to the world's largest electrolyzer, can you please describe shortly what is interesting for customers about your high-pressure alkaline electrolyzer, and what are the advantages compared to other electrolyzers?
Well, there's one parameter that is important for the customer at the end of the day, and that's the amount of euros or dollars they have to pay per kilogram hydrogen produced. And this is a combination of investment cost and operating cost. If you take a typical electricity price you can achieve for industrial projects in Europe, probably between 30 and 50 euros per megawatt hour. For a typical normal scale plant, around 50 to 75% of the total costs are related to electricity cost. So first of all, you need a very efficient plant. Then you need to have as low investment cost as possible. And also here we can offer very attractive products. I would like to mention the latest project our Chinese colleagues work with. They're working on a 4,400 normal cubic meter per hour plant. This is equal to 90 kilograms of hydrogen per hour, which again equals 20, now I do the math correctly, 20 megawatt plant. So it's a very large plant they're offering to a photovoltaic industry in the north of China, close to the Mongolian border, in the city of Urumqi. And what is special with this plant is it consists of 2 electrolyzers with a capacity, nameplate capacity of 1,000 normal cubic meters. So this is probably the world's largest pressurized electrolyzer you will find on the market. And then they have 4 units of 600 cubic meters, all providing a pressure of 16 bar. So what we promised last year when we were here in Hanover, we said we come back with 1,000 cubic meter. This is real, and this is proven technology.
Coming back to this 1,000 to the big plants, which improvement had to be done that you increase even the 800 cubic meter per hour up to 1,000 cubic meters?
Well, you see, this is a beautiful thing about this technology. We have incremental development steps. So we are not taking the big steps. Developments in electrolysis world are very costly. So you have to make sure that the steps are confirmed underway. And we have slowly come all the way from 600 to 800 cubic meters. And then just by redesigning parts of the system, we can adapt to 1,000 cubic meters. So we have higher current in the stack, and of course the balance of plant has to be adjusted to the new output.
We are talking about the world's largest electrolyzers now. With such a big application, you mentioned to meet the industrial hydrogen demand. And you seem to be very enthusiastic about that. Where does your optimism come from?
Well, we have proven technology. With a long track record, we know that our technology works. We can take our customers to existing plants and show how the electrolyzers work. And from there, we can upscale the plants easily because our systems are modular. You take one electrolyzer with a gas separator module, and then you just multiply this to add up to large plants. And what we see now is, electrolysis is nothing new. Electrolyzing has been used in industrial applications for more than 100 years, but we see now a trend towards renewable energy applications, and there are some new requirements in terms of operational flexibility. And say wind or solar power, they have intermittent power. And with our pressurized system, we can accommodate this fluctuating input fairly well, but in an operating range between 20 and 100% of the nameplate capacity. Okay.
You mentioned the power coming from wind power plants. Are there already electrolyzers existing that are fed by power from renewable energies, like a solar power plant?
Well, to best of my knowledge, only in smaller scale. This has to be looked at depending on where you are geographically. The place where we, in Norway, we have an abundance of hydroelectric power, so that it makes little sense to just connect the electrolyzer to a solar power plant, because you would probably only operate your plant a few % of the total time. So in order to get an optimum cost picture, operate the plant as much as possible, and in most places for large applications, I would guess the optimum picture is to have a grid connection as well.
Okay. And now, looking to the future, if we want to produce green hydrogen, what do you think? Which renewable energy plants could deliver power for such big hydrogen production, or is it a combination of several feed-in?
Well, again, it's depending on where you are geographically located. We are looking at a number of interesting projects up in Scandinavia, where power is very reasonable priced, and there it makes sense to produce hydrogen, and you need to have also a customer for the hydrogen. It doesn't make sense to produce thousands of tons of hydrogen and nobody is using it. So there we're looking at projects which go to synthetic fuels, and in other places you might want to produce methane, or you can even think of feedstock for chemical industry. So I think this would be the big next step, where you replace chemical feedstocks, or also steel industry, which could use abundant amounts of hydrogen.
Very interesting. You mentioned methane already. Power to X technology is the topic there. It becomes more interesting, and the more and the lower the energy price from renewable energies fall. Is there already an example where your system is combined with methanization, for example?
Yes, actually we have the company CRI in Iceland. They have been supplied with our electrolyzers and then produce methanol, synthetic methanol based on CO2 and green hydrogen.
Okay, if you want to give an outlook to the next years, do you think the power your plants will even increase in size even more, or do you just then focus on special markets like chemical industry, where hydrogen is a big demand?
Well, we certainly will focus on all market segments because that's of interest, where chemical sector and the energy market is most important. I don't think we will be looking at a further increase of the electrolyzer in the near future, because what we're looking at with large plants, the next step will be to cost optimize these plants and to look of ways how to go from manufacturing to a serious production of these electrolyzers.
Mm-hmm. Okay. And again, to the topic decarbonization of the industry, what do you think? How long will it take to decrease the CO2 emissions by hydrogen?
This is a very difficult question. I don't have the answer. I think this is a political issue. It could be done much quicker than it's actually done right now. We have to substitute fossil fuel energy carriers and replace them with green carriers. And I think it's political boundary conditions which need to be in place. And at the end of the day, it's up to everybody here, every individual, to make a choice in daily life to choose a green alternative.
Okay. And looking to the audience, what do you think? Who should come to your booth after our interview now?
Well, everybody who is interested in large-scale hydrogen or even small units. We also supply containerized solutions up to 200 normal cubic meter and up to 50 bar. So this is a very interesting proposition for those who want hydrogen on site.
Okay, thank you for this very interesting interview. You can find Dr. Fell and HydrogenPro at booth number C48. It's up in this direction. And yes, thanks a lot for answering my questions.
Thank you so much.